In this lesson, we're going to discuss the means by which blood is supplied to the human brain. The blood supply to the brain comes from below. So in order to inspect those vessels, we need to look at the inferior surface of the brain. Blood is supplied to the brain through two major pairs of arteries. Towards the anterior side of the brain, those arteries are the internal carotid arteries. Here's the left internal carotid artery, and then here is the right internal carotid artery. These are the two major arteries that supply what we call the anterior circulation. The posterior part of the brain and much of the spinal cord is supplied by a different pair of arteries. These are called the vertebral arteries. Here is the cut end of the right vertebral artery, and right next to it is the cut end of the left vertebral artery. The vertebral arteries contribute what we call the posterior circulation. So let's talk about these two major circulations to the brain, beginning with the posterior circulation. These vertebral arteries arise and enter the cranium, and then they join together to form a single midline artery called the basilar artery. And that's what we see right about the junction of the medulla and the pons, is where the two vertebral arteries fuse. And then the basilar artery runs up along the length of the pons towards the midbrain. Now, along this length of this posterior supply, there are branches that supply the brainstem and the cerebellum. Just below this cut end of the vertebral artery is a junction of a branch right here called the posterior inferior cerebellar artery. So this artery, which is cut in this specimen, attached to this right vertebral artery. The posterior inferior cerebellar artery supplies, as its name applies, the posterior and inferior aspect of the cerebellar hemisphere, as well as giving rise to branches that supply the lateral part of the medulla. Now, typically, just after the junction of the vertebral arteries to form the basilar artery, we have two additional arteries that supply the brainstem and the inferior part of the cerebellum. These are called the anterior inferior cerebellar arteries. And here we see them on either side of the lower portion of the basilar trunk. So these, again, are the anterior inferior cerebellar arteries. Now, near the top of the pons, where the basilar artery is about to split and form two major cerebral arteries, there are two branches that supply the superior surface of the cerebellum. These are the superior cerebellar arteries. Here is the left superior cerebellar artery, and then over here, I think you have a better view of this, there's the right superior cerebellar artery. Now, as these arteries wrap around the brainstem, they give rise to short branches that supply the lateral and dorsal aspects of the midbrain and the pons. Now, along the length of this basilar artery are numerous short branches that supply the interior structures here within the pons. And these vessels are very small, very fine, and sometimes they clot and produce strokes in the brainstem that can have a variety of consequences depending upon what structures are injured. Now, let's try to look deep into this central region on the ventral surface of the brain and see what happens to that basilar artery. The basilar artery, just anterior to the superior cerebellar arteries, splits into two parts. One branch goes to form the posterior cerebral artery in one side, and then the opposite branch forms the posterior cerebral artery on the other. Now, in order to get a better view of those cerebral arteries, we need to look at a specimen where the brainstem and the cerebellum has been removed. Here's a specimen where the brainstem and cerebellum has been removed, so we can see what happens to the posterior cerebral artery at the top of the basilar trunk. What we see here are blood vessels that extend along the inferior surface of the temporal and occipital lobe, and then along the medial surface of the occipital and temporal lobes here. These are branches of the posterior cerebral artery. And right at the junction of the basilar and it's split into a left and right posterior cerebral artery, there are small branches that supply the adjacent structures here in the midbrain. Well, that concludes our survey of the posterior circulation. Now let's look at how the posterior circulation meets the anterior circulation. So to do that, we need to go back to the specimen where we have a clear view of the blood vessels on the ventral surface of the brain stem and the diencephalon. Now we've got our first specimen in hand again, and we want to follow the posterior circulation to its junction with the anterior circulation. So again, the posterior circulation arises from the two vertebral arteries that join to form the basilar artery, which then runs along the midline of the pons, and in the region of the midbrain, that basilar artery splits into two posterior cerebral arteries that supply the inferior surface of the temporal and occipital lobes. Now, there are short communicating arteries that connect that posterior circulation to the anterior circulation, and we can see them right here. In this brain, they're actually quite prominent. This is called the posterior communicating artery, and it connects the posterior cerebral to the internal carotid. So there we have our right posterior communicating artery, and then on the opposite side we have our left posterior communicating artery. In this brain, these arteries are quite symmetrical, but it's not unusual to find a marked asymmetry in the dimensions of these two posterior communicating arteries. Okay, so this is the means by which the posterior circulation meets the anterior circulation, which is derived from our internal carotid arteries. Here's our left internal carotid and our right internal carotid. So now let's discuss the anterior circulation. These two carotid arteries give rise to two large branches. One branch runs in the anterior direction, just on top of the optic chiasm, and that forms an artery called the anterior cerebral artery. The anterior cerebral artery begins right there at the tip of my pointer, and it continues along the midline of the hemisphere. And if I gently separate these two hemispheres, we might be able to see the junction of the anterior cerebral artery and the midline of the hemisphere. And what happens here is that there are two anterior cerebral arteries, one that gives supply to the left hemisphere, one that gives rise to the right hemisphere. And if I gently reflect away the optic chiasm, I think we can see those arteries as they come together. And there is a short anterior communicating artery that connects the two anterior cerebrals. So just in front of my pointer, we see just a small little touch of an artery that allows the two anterior cerebrals to communicate. Now, to really see the anterior cerebral artery, what we want to do is we want to look at the mid-sagittal plane through the hemisphere and see that artery as it supplies the medial face of the hemisphere. So now that we have a brain that's been sectioned in the mid-sagittal plane, we can see what happened to that anterior cerebral artery. So here's the anterior cerebral artery, right where it is coming off the internal carotid. And we see that this anterior cerebral artery gives rise to branches that wrap around the cerebral cortex on top of the corpus callosum, supplying this cingulate gyrus and the superior frontal gyrus, all the way back through the region of the paracentral lobule. Now these arteries have been cut right about in this position, so we can't follow them all the way back, but I think we can see very nicely how this artery hugs the medial surface of the hemisphere as it supplies the frontal lobe and the paracentral lobule. In addition to the anterior cerebral artery, the internal carotid gives rise to one more major arterial supply to the brain, and that's the middle cerebral artery. In some hemispheres, it appears as though the internal carotid just keeps on going, penetrating through this space between the temporal lobe and the frontal lobe. That space is the lateral fissure. And indeed, once we get beyond the junction of the anterior cerebral artery, the internal carotid is known as the middle cerebral artery. And this artery runs through that lateral fissure, supplying blood to the temporal lobe and the inferior surface of the frontal lobe, and emerges on the lateral surface of the brain. And underneath this arachnoid tissue, we can see branches of the middle cerebral artery as it supplies roughly the middle central portion of the cerebral hemisphere. So all of this cortical region, including the central part of the parietal and frontal lobe and the superior part of the temporal lobe, is supplied by branches of the middle cerebral artery. So far, what we've discussed is the arterial supply to the brain. But to complete the story, we have to talk about the venous drainage of blood to the brain. And for that, we want to inspect a sample of dura mater. This is the tough tissue that surrounds the outside of the brain. In fact, dura mater is one of those great words in brain anatomy that is exactly what it means. Dura mater means tough mother. So this tissue is a very tough, leathery sort of protective covering on the outside of the brain surface. However, in certain places, this tissue separates into two layers that form a venous sinus that allows blood to drain out of the brain. One such venous sinus is right along the midline here. So imagine this bit of tissue sitting around the brain such that the space between the hemispheres would be right here. So this sinus is called the superior sagittal sinus. And in fact, on the back part of this dura, we've made an opening so that we can see a bit of that sinus space. In fact, I can put the wooden stick right into that sinus so that you can see that there is indeed a bit of a triangular shaped channel right along the midline of this tissue that allows blood to drain from the cerebral hemispheres. That blood then meets another sinus space, which is in the back part of the cranium, right in this region. This is called the confluence of sinuses because the superior sagittal sinus and two other minor sinus systems drain into this receptacle, and from there the blood flows transversely through another space within this dura called the transverse sinus. And again, I can put my probe through there to demonstrate this space through which blood is leaving the cranium. So this transverse sinus then forms a structure called the sigmoid sinus, which then exits the skull through the jugular foramen as the jugular vein. And by this system of dural sinuses, blood is drained from the brain and returned back to the venous vascular system, which enters then the heart and is once again circulated through the pulmonary vessels. One other point about the dura, well, it's in my hand. This is the outer surface of the dura, and here's that superior sagittal sinus. If we look on the inside, we see a flap of tissue called the falx cerebri, which forms a bit of a separation between the two hemispheres. So this bit of dura sits right between the left and right cerebral hemispheres, with this inferior margin of the falx being a small narrow sinus that allows blood to drain from deep within the brain. And so this bit of tissue sits right on top of the corpus callosum.